So section 2.3 is the sine law. Really, the first two sections of this chapter are building up essentially to the sine law. Okay, the sine law. So what we're basically going to talk about are three situations. Situation one, we're going to be given a couple sides or a couple angles. We're going to have to find a side of a triangle. Situation two, we're going to be given a couple sides and an angle, and we're going to have to find the other angle of a triangle. And the last one, we're going to talk about the ambiguous case. Okay, the ambiguous case. When it comes to the proof of the sine law, I'm not going to go over it. It's in the notes, but I will show you the sine law, and that is it. This right here. So here's the sine law. So given triangle ABC down here, okay, side A over sine of angle A, okay, is equal to side B over sine of angle B, and that is equal to side length C over sine of angle C. Or you can write it the opposite way, like you can see right here. Okay. The proof of this is quite straightforward, and you can read it through here. But we're going to get right to an example. What can you do this for? Okay. What can you use this for, I should say? So the first type of example we're going to talk about is determining an unknown side length. So this example I did with a worked through solution in the notes, as you can see. So hopefully you've tried the practice problem associated with it. I'm going to go through the solution of that right now. So given triangle ABC below, use the sine law to determine the length of side length A. Right there. So what are we going to do? Well, let's get our let's change color here to red, and we are going to use the sine law. Now I will change. I'm going to use all the way back here. I'm going to use this particular version of the sine law right now because I'm looking for a side length, and so it's already on top. If I was looking for an angle, I would use this one. That's how I will flip back and forth. Okay, I'd like to have the variable I'm solving for starting on in the numerator, but it doesn't matter. You can use either or. So I'm going to use this particular version of the sine law. And you only need two fractions. This is a ratio to solve for what we desire. We need to know three things. We need to know angle A, which is 61 degrees. We need to know angle B, and we do, it's 88 degrees. We need to know side length of one of these two guys. Okay? In this case, we actually know the side length of C. We actually know the side length of C, which is 1.8. I'm going to complete the sine law up here. That's the full deal. If we knew B, we could go ahead and solve this. We could solve for A if we knew B right away. If we knew angle C, we could solve for A. We don't know either, so we're actually going to have to solve for one. We can easily find what this angle is right here by going 180 degrees. So angle C is equal to 180 degrees minus 88 degrees. Right, the sum of the interior angles of a triangle are equal to 180 minus 61 degrees. Yeah, let me grab a calculator. So that's 180 minus 88 minus 61 comes out to be 31 degrees. So I'm going to use this form of the sine law. I'm going to use angle A over sine A is equal to C over sine C. We don't know what A is. We know what sine of A is. Okay, 61 degrees there. C, we know what that is. That's 1.8. and we're going to go sine of what we found here, that's 31. We're now going to multiply both sides by sine of 61 to isolate a. That will give us this guy right here. There we are. 31 degrees. And now, as long as your calculator's in degrees mode, we can go ahead and solve this. Sine of 61 times 1.8 divided by sine of 31 comes out to be 3.06. To one decimal place, this is 3.1. And that is what a is equal to. And there you have it. Okay? That's one version, or one application of the sine law. The next question will be solving for an unknown angle. Okay? Here's an example. Again, solutions are in your notes for that example. Let's go ahead and solve this. Practice 2. In triangle LMN, okay, angle L is equal to 64 degrees. Side length of L is 25.2 and M is 16.5. Determine the measure of angle N to the nearest degree. And of course, drawing a picture will help visualize this problem. Let's draw a picture. Okay, 64 degrees is what we call an acute angle. Okay, doesn't have to be perfect. But let's just say this is 64. That's angle L. The side length is 25.2. That is little l. And opposite of M is a side length of 16.5. So we're looking for angle N, which is this angle right there. That's what we're looking for. Okay, so let's go ahead and start this. This time I'm going to place angle N in the numerator. We know we're going to have that. Right away though, we actually can get right into solving this because, and I apologize, I'm sorry, let me just before I plug stuff in, I should write it out. That is the formula we're going to use right there. Okay, I put the angles on the top because I'm solving for n, for angle n, sorry, big N. So here we go. You can solve this, you can rearrange this for n right away, but I'm going to plug stuff in. Okay. Once again, in this situation, in this question, we're not given n over here. We're not given this. Okay, we're only given right now. We know what we know what L is. We know what little l is. Okay. We can't use our little trick about angles. Okay. But once again, what we can do is we actually can solve for angle M first. Okay, so let me extend this. So you'll see that you'll probably write stuff out like I did and realize you don't have enough information. But then you have to remember that you can always extend this and work out from where from the known variables that you have. Okay, so ignore this guy for a second, and we're just going to focus on this guy right here. Okay, we can solve for big M. Once we have big M, we'll be able to easily do our sum of interior angles to being 180 to solve for N. That'll be the strategy. So here we go. We're going to go sine of 64 degrees over L, which is 25.2. And we're we're going to have sine of m. We're going to do this all over little m, which is 16.5. Okay? Now, solving for m, we're going to have 16.5 times sine of 64 all over 25.2 is equal to sine of m. You're going to take the inverse sine function of both sides. Okay? So you're going to have sine inverse of all of that, and you're going to be left with just m over here. So in the end of the day, when you plug this in your calculator, you're going to have 16.5 times sine of 64 divided by 25.2, and the answer will come out to be, to the nearest degree, 36 degrees. Now we can finally find n. N is equal to 180 degrees minus 64 degrees minus 36 degrees. When you plug that into your calculator, you get a lovely value of 80 degrees. Okay? So, those are the first two examples. This will be part 1 of section 2.3. Part 2 is going to deal solely with one question, and that is the ambiguous case.